So I'm excited to share with you guys today what it looked like to migrate from our data warehouse at DoorDash, why we did it, and some of the challenges we faced that might help your organization move through a migration similarly. So just a little bit about me. My name is Eric. I studied computer science at Stanford before going to DoorDash and being a software engineer on their data platform team. I love distributed systems and got to work on setting up Trino and Spark at DoorDash, which was awesome. Some personal things about me. This is like my third slide deck of the week, so I was kind of churning through these. But when I refer to a data lakehouse, I know that can kind of mean a lot of different things to a lot of different people. So I think it's worth kind of addressing what I'm referring to when I talk about a data lakehouse. And when I say that, I basically just mean storing your data in kind of a generic cloud object storage like S3 or GCS and querying it directly from there. Which sounds relatively simple, but there are kind of a lot of moving parts that need to get set up in order to get this functioning properly, especially at scale. And so the core components are, of course, you need to have somewhere to store your data, so that will be like your Amazon S3, some file format, whether that's Parquet, Avro, or ORC, to actually store the data in files in that file storage, as well as a meta store to store the table metadata so that your analysts actually know which tables you have access to, and to actually translate those files from underlying files into tables that mean something semantically to the analysts, as well as access control top to bottom of the stack so you can control who has access to the data, which shouldn't be overlooked, and a query engine to actually process the queries submitted by the analysts. So this will be your DuckDB, your Trino, your Spark, actually accessing the underlying files. Some things that are nice to have but not entirely necessary are table format. You can access the data directly as files, but it will be a little bit harder for your analysts. So everywhere we see people setting up a data lakehouse, sometimes they'll call it data lake, they will still have a table format. Some kind of semantic catalog to make actually discovery of the data a bit easier. Monitoring and observability to help you set up, to help you understand how resources are being used around your organization, and basically making sure that you're utilizing your resources correctly. Compute is consistently a top 5 enterprise expense, and not keeping track of your compute costs, whether that's on a fully managed warehouse or on a lakehouse you built yourself, is kind of a common pitfall. As well as thorough documentation, which we all know about, we all don't like to do. So why a lakehouse? Why would you move over from something that's fully managed in such a nice world and the Snowflake and the big queries where you just put data in and get data out? It turns out that there's a lot of reasons that you might do this. A lot of them have to do with kind of cost effectiveness and performance at scale, but a lot of them actually have to do with flexibility in terms of how the data is organized, how the data is accessed, and one of the big concerns for us at DoorDash was actually being in a leveraged position against some of our vendors. We felt we were in a position where having all of our data stored in something like Snowflake or BigQuery, we were kind of at risk of getting our rent raised kind of unexpectedly, but storing our data in S3 really future-proofed us as an organization. So with all that said, this is a privilege that's usually reserved kind of only for large teams that can afford to bring on 5 to 7 engineers to build that data platform. But we think it's becoming easier and easier for smaller teams to kind of have this option. And so here to talk today about if this is something your organization is considering doing, some of the things you might face. So the first thing you'll have to do is kind of select how you're going to move that data over. You usually don't want to wholesale kind of copy all of your data into S3 and move it over. You'll generally not do like a rip and replace, but more you'll identify kind of the workloads of highest consequence based on whatever characteristics are important to your organization. We found that actually tables that analysts wanted a high degree of freshness of, meaning from the time it's produced to the time they query it, they want it to be really low latency. Those were really good use cases for us because they would go through relatively little transformations. So they had very few dependencies, they were very high value, and we can run those kind of as exploratory tables that they could get access to directly into the data lake. And they usually had very loose constraints on kind of data quality relative to data sets that would go through more transformations. So some examples of that were interactive analytics, where you just kind of want to see what's available in production. Basically anything that you would like to just go straight to Postgres for. You'll go through the trouble of getting that into S3 for kind of long-term storage, but move through that pretty quickly. Then the next thing you have to do once you have your data over is actually register the files underneath as tables. So this is kind of the Lakehouse part that adds warehouse functionality to the data lake. So this lets you do things like time travel, ACID transactions on the data lake. This makes it really easy for analysts to have that smooth SQL experience directly on files. And so this is just a thin software layer that kind of translates those files into tables. The table metadata will need to get stored in some kind of metastore. If you want to go the self-managed route, you'll probably do something like Hive, whereas if you want to kind of have a smoother experience, you might use something like AWS Glue, though that is kind of reserved for a specific ecosystem, if you're in the AWS ecosystem. There's been kind of a lot of hype about this over the past 12 to 18 months, but it's really unlocked a lot of value for people that are on data lakes, and so we think there will continue to be an emergence of people kind of moving from the warehouse onto the lakehouse because of this reason. Of course, you can't ignore access control and security, and I think that this is something that we overlooked early on in our journey. Once you have all the tables set up, you actually need to manage access control not only of the data itself, but doing authentication at the query engine level and all the way kind of down the stack. So what we used was Apache Ranger. We had a lot of trouble with Apache Ranger, though it's still kind of in production today. There are kind of managed versions of that, like Privacera, that you might use. Whatever you end up going with, I think this is just something that we took for granted and didn't realize until after we kind of started having some access control issues, mostly with different systems that needed to communicate shared access controls. So we were building this separately compared to our Snowflake access controls, and actually had a lot of trouble getting those kind of mismatched. So in retrospect, I would have wanted to front load a lot more of that work and really pay attention to access controls earlier on in the migration. Now, this is something that I personally spent a lot of time with, which was establishing workload parity. So for us, in order to actually make sure that we were able to get the data workloads onto the lakehouse and working properly, we not only needed to ensure that they were performing similarly, but that they were actually the same queries in the first place. Snowflake has its own SQL dialect. BigQuery has its own kind of standard, but a little bit different SQL dialect. And what we were actually using and moving most of our workloads onto was Trino. You can use a SQL translator, like something like SQLglot, for example, does a really good job of translating a good 80% of the queries. Anything that is a very standard SQL function will be very easy to translate. But fair warning, it will not directly translate all of your queries. You still do need to go through the trouble of establishing parity on the result sets of those queries. A lot of the trouble we ran into was actually with kind of user-defined functions that were created in Snowflake, so not kind of anything built into Snowflake, but all of those custom functions that the users had made over the years were kind of the biggest challenges in translating those workloads over. So again, back to choosing which data sets to start your migration with. You want to choose the ones with relatively little dependencies. We found that those actually had a lot less user-defined functions floating around. And so the main thing here was we didn't have a clean way to know that the result sets were the same, especially for large result sets. I think we were able to use something like data diffing tools, I believe it was Datafold, to help us kind of see the differences between the result sets. But this was something that we struggled a lot with, just in terms of gaining trust around the organization. So it's easy enough to kind of look at the result set and eyeball it and say, you know, this looks approximately the same. But if your users are starting to kind of see their queries deteriorate, you will lose trust very quickly. And in any migration process, trust will be the first thing to go and then the hardest thing to get back. So you really want to make sure that you're making that migration smooth for your analysts and not butchering result sets. Now, this is actually where I spent most of my time personally, was in setting up the query engine over the Lakehouse. There are a lot of decisions from the bottom to the top of the stack that affect query performance. At the storage level, I think that this gets overlooked by people shilling compute engines, but the way that the data is organized actually has a huge impact on the way that the query performs. If your analysts are accessing data that's far apart, they will have worse performance than if it's closer together. And so you have to make decisions about how that data is organized that often gets abstracted away in a fully managed vendor like Snowflake. You put the data in and they handle everything from clustering, partitioning, and compaction. But when you start moving over to something like a data lake or Lakehouse, you actually have to make decisions about all of the ways that your data is organized and stored. But even after that, if you're setting up a query engine, even if it's something as simple as DuckDB, but especially if it's something like a distributed system like Trino or Spark, you will have a lot of decisions to make about the number of workers, the types of machines you're using, the types of servers you're using, as well as kind of the memory and CPU settings per machines. We found in the early days it was best to kind of over-provision for the workload so that the analysts would come on and have a good experience early on. But as their workload started to stabilize, gradually trying to cut down on the resources provision so that we would avoid leaking costs. So in the early days, we had something like 10% CPU utilization across our clusters. But we're targeting 60 to 70% over the next 6 months of CPU utilization so that we can minimize resource waste, because this is where most of the cost is. It's also where most of the cost savings is compared to something like Snowflake. So running your own EC2 servers and using that to query your data will be a lot cheaper than running a managed engine. But you still need to be careful not to be spending 50% of it just because you can. And then on the analyst side, and this is actually something that I think as a platform engineer I overlooked. I didn't talk enough to my users, but I found that they were having to really understand the nitty-gritty of how the query engine that we were using worked, because we weren't doing a good enough job at kind of educating them about best practices around their queries. So I think the benefit, again, of like a fully managed warehouse is that queries just work, but we had to be a lot more conscious about the join order of our queries, as well as using partition keys to avoid full table scans. So kind of top to bottom here, there's a lot of work that needs to be done to ensure kind of efficient system performance that you just kind of get to ignore if you're on a fully managed warehouse. With all that said, though, so I kind of touched on this a little bit. You will want to have visibility into who is using your system, how they're using your system. We found that it was great to have a shame list of people that were kind of overusing the queries, so that we actually knew who our users were and who to approach about kind of inefficient system. So often we would have one query that would kind of dominate the entire Trino cluster, and we would have to kind of address those users and kind of tune the system for their queries if it was appropriate, or tell them to stop running queries if it wasn't so appropriate. And then the last thing that I think was the biggest thing that we overlooked was just education. As with kind of a lot of developers, I, in the early days, built a platform and expected people to use it, and I expected people to know how to use it, but actually found that education was a huge hill to climb for us. Everything from being active in Slack channels to sending out active newsletters to putting out kind of tutorials and stuff for a lot of the query stuff that I mentioned as far as query optimization, and teaching them the ins and outs of kind of the new platform that were new compared to their experience on Snowflake. Our analysts really love Snowflake, but it was really expensive for us. So as we made the migration, we had to ensure that the new experience was as close to that fully managed, fully kind of manicured experience as possible. And that meant teaching them a lot about how the system works, which might be more of a bug of the system than a feature, but it was something that we kind of needed to support. So I know that I kind of covered a lot in a short time, kind of at a high level, but those are kind of just what the 9 months of the migration process looked like for our first handful of workloads. And I'm happy to dive deeper into any one of those sections after the talk as well. Yeah, thank you guys for listening. Appreciate your time.